I've been waiting for more than a year for this printer, and many of you have too. I know this because you won't stop asking me if I've heard anything about it. Well, the day has finally arrived, and surprise, it's twins, and one of them has a freaking laser. Let's talk about it. Welcome back to Cloud 42. My name is James, and this is the H2D 3D printer from Bambu Lab. And this is also the H2D 3D printer from Bambu Lab. The main difference is that this one is just a 3D printer, and this one also has a laser and a blade cutting attachment. I've had the laser or L version of the printer for a little more than a month, and in that time I've put close to 300 hours on it, so I feel like I have a pretty good idea of what it is and what it isn't. But before we get into that, some disclosures. These printers were provided to me free of charge by Bambu Lab, probably because I wouldn't stop asking about them. I agreed to use them and provide feedback, but it's up to me when or even if I want to show them on the channel. Bambu Lab isn't paying me any kind of fee for making this video or promoting their products, and they have no control over what I say. But I do participate in their affiliate program, so there will be links to these printers in the video description, and if you use those links to buy something, I earn a commission that helps support the channel. My goal, as always, is to be as transparent as I possibly can be, so keep my incentives in mind as you consider what I have to say. So what exactly is this thing? If you're familiar with Bambu Lab's other 3D printers, the H2D should look pretty familiar. Like the X1 Carbon, it's a fully enclosed Core XY machine, and that's pretty much where the similarities end. The H2D is larger, with a build volume of 350 by 320 by 325. It has an actively heated chamber that can reach 65 degrees, and hot ends that can reach 350. The printer has a die-cast metal frame for the Core XY mechanics, and you can see part of it through the side windows, but the really pretty stuff is only visible if you take off the back. It has a new servo-driven extruder that can monitor torque to detect clogs and partial clogs, as well as filament slippage and grinding. The extruder has dual nozzles, which help reduce waste from filament changes and also allow it to print dissimilar materials, including TPU. It has a vision-assisted encoder system that can map and calibrate the mechanics, and they claim it can achieve motion accuracy of 50 microns. The machine has an active ventilation system that can seal the chamber for high-temperature printing or open vents to draw in fresh air. The exhaust is filtered, but it can also bypass the filter to use an external smoke extractor for laser processing. There's a separate laser bundle version of the machine that has a blade cutter, a 10-watt diode laser, and a built-in air assist pump. An optional 40-watt laser module is available. It has laser safety windows, flame detectors, a bird's eye camera for setting up jobs, and an external emergency stop switch. With the H2D release, there are also two new AMS units. The AMS 2 Pro is a 4-spool unit with a built-in dryer that can reach 65 degrees, and the AMS HT, or high temperature, is a single-spool unit for high-temperature materials with a dryer that can reach 85 degrees. The machine is sold in two versions. The standard version, which is just the 3D printer, sells for $18.99 US, and in a combo with the 4-spool AMS, it's $21.99. The laser, or L version, is sold as a combo with the 4-spool AMS, the blade cutter, 10-watt laser, safety glass, built-in air assist pump, and the e-stop switch for $27.99. With the 40-watt laser, it's $34.99. The single-spool high-temperature AMS is sold separately. There will be upgrade kits available to add the laser and blade cutters along with their safety features to the base printer, and they also sell a smoke extraction filter to deal with the laser processing fumes. As far as reviews go, this one might be a little bit different from what you see elsewhere. I don't really consider myself a 3D printing enthusiast, I'm more of a power user. To me, the 3D printer is just a tool. It's not a hobby. I do think all the fancy technology in these newer machines is neat, but in the end, it doesn't matter. What I care about is if it works, if it does the thing. I want a printer that produces what I expect on the first try every time. I want to reprint because I'm iterating on the design, not because the print failed, and definitely not because I'm tuning the printer or dialing in filament. I want the manufacturer to do that. I want them to tune the machine and develop the profiles. I want the software ecosystem to be integrated end to end. I want the workflow to be simple, and I want it to just work. To get that, I'm willing to use the manufacturer's software as long as it's good, and I'm willing to buy their materials as long as they're reasonably priced, and I'm willing to use their cloud services as long as they're reliable. If that sounds like what you want from a 3D printer too, keep watching. I've got lots of details to share. I've tested a lot of 3D printers from a lot of brands, and Bambu Lab is one of the best at getting the printer set up and working right out of the box. The experience with the H2D was no different. I pulled it out of the packaging, powered it on, and it walked me through the setup and initial calibration. When you plug something new in, like the cutting module, it walks you through the needed calibrations automatically. This printer has sensors everywhere, and they really take advantage of that to eliminate things that you have to do during the setup, which also eliminates opportunities for you to make mistakes. For instance, when you connect an AMS, the printer needs to know which nozzle it's connected to. But instead of asking you to tell it that, it just asks you to put in a roll of filament, and it feeds it into the printer and uses the sensors in the buffer to figure out how you have it connected. There's also no need to calibrate the offsets for the two nozzles. Other multi-nozzle systems, including the one I designed back in 2014, require calibration test prints. The Prusa XL requires you to install a pin and let it probe, but this printer just handles it. It has an eddy current sensor that it uses to measure the offsets at the beginning of each print. Because it doesn't depend on mechanical contact, it isn't affected by debris stuck to the nozzle, which is pretty neat. But the value of it is that it just works. In the information packet they sent with the printer, they said something interesting about all of these automated features. Quote, "We hope you don't even notice that it's happening." And that's really what they've delivered. It didn't even occur to me until after I'd done several prints that I never calibrated the offsets. Everything in the machine is like that. There are cameras everywhere too, including under the tool head looking at the nozzles. There are targets on the heat bed so it can automatically align the bird's eye camera. There are 2D barcodes on the nozzles and it checks them with the live view camera at the beginning of every print to see which ones are installed. They even sell a calibration plate with a bazillion tiny barcodes on it that the printer can scan with a down-looking camera on the tool head to map and compensate for imperfections in the motion system. Incidentally, they do include a magnetic privacy cover for the live view camera since it can actually see out through one of the side windows. The control panel is bright and clear. I found everything intuitive and easy to use, and they've incorporated some fun little details and happy sounds that, aren't really needed, but make using it a pleasant experience. I will say that I really don't like the green glass on the laser version of the machine. I get it that it's there for laser safety, and it's really nice to not have to wear safety goggles when you're using the machine, but it makes it hard to watch your prints. I constantly find myself leaning over to look through the top glass like I do on the X1, but it's opaque on the laser version of the machine, which is kind of annoying. The chamber camera is pretty good, and it displays the video feed on the control panel when laser cutting, which helps, but I wish they had that available while printing. Bambu Lab, if you're watching this, and I'm pretty sure you are, I want that feature. The print-only version has the same smoked glass as the X1, so that's less of a concern. I also own two X1 Carbons and an X1E, and relative to those machines, the H2D has a number of noticeable improvements. Obviously, it's bigger, and like the X1E, it has a heated chamber, but it's also quieter, which kind of surprised me. The motor noise cancellation works really well, and unless I'm paying attention, all I really hear is the fans. I've actually gone in and checked on it because I thought it had stopped printing. It hadn't, it was just quiet. By contrast, I can hear my X1s from outside the room, and I can hear my Prusa XL from the other end of the house. The H2D also has much better nozzle cleaning than the X1 series. I've always kept a pair of tweezers next to every 3D printer I've ever owned so I can watch the start of the print and pull off anything that sticks to the nozzle. Especially with sticky materials like PETG, things can build up or the purge material can stick and get pulled out of the poop chute and onto the bed, where it causes the auto bed leveling to fail. The H2D seems to have completely solved this problem. It's got little metal flicker plates and silicone wipers and a perforated metal scrubbing plate, and in 300 hours of testing, I have never seen the nozzle cleaning fail, and every first layer has been essentially perfect. I had one job that ran 2 spools of PETG carbon fiber through the machine over the course of 34 hours, and when it switched spools to finish the job, it even cleaned off the junk that had built up on the sides of the nozzle from 24 hours continuously scraping over the infill. The startup sequence has also been dramatically simplified. The bed heats up fast. It only probes the area of the bed that will be used for the print, and then instead of printing a bunch of lines that either peel off the bed and cause problems or stick so hard you can't get them off later, it just puts down a single blob of filament, then drags out a line and starts the print. It also comes stock with vibration damper feet, which might be part of the reason why it's so quiet. The automated vents open and close based on the filament being used, so you don't need to open the door when printing PLA like they recommend on the X1, and that's actually more convenient than I expected. And the built-in air filtration also seems very good. I'm sure someone will do particulate testing, but what I can say is that I can't smell anything when printing ABS and nylon. With most of my other printers, I can smell them from the next room, but with the H2D, I don't smell anything. It's another thing I didn't even think about. I'd run several prints before I even realized I wasn't smelling the fumes. So why on earth would you want dual nozzles? That seems like such a 2014 solution. Well, the headline reason that gets all the attention is less poop. The fewer times you have to purge out the hot end, change materials during the print, the less waste gets generated. But there are also other benefits. Having multiple nozzles allows this printer to do multi-material prints with soft TPU. This is just not possible on other Bambu Lab machines because the TPU is too soft for the printer to automatically load and unload during the print. In the H2D, you can just load the TPU manually into one nozzle and leave it there with all of your other materials in the AMS on the other nozzle. It also prevents cross-contamination though. If you've ever used PLA as support material for a PETG print, you know that residual PLA left over in the hot end mixes with the PETG and causes it to become weak and brittle. You have to radically increase the purge volume to get it to work, which produces more waste. But with 2 nozzles, you can just keep them completely separated. Now, there are some limitations though, besides the fact that there are only 2 nozzles. They recommend running soft materials only in the right nozzle because it doesn't move up and down like the left nozzle does. But they also recommend attaching your AMS to the right nozzle, so that would mean switching it over when printing TPU, which is kind of inconvenient. Now, I was actually running my AMS on the left nozzle for most of my testing because I didn't read the manual, and I didn't see any issues, so I don't know how much it really matters. They're probably being overly conservative just to minimize issues would be my guess. Now, the biggest concern I personally had when I saw the dual nozzle design was ooze. That has been the bane of every multi-nozzle printer I've ever used, even the XL. But Bambu Lab seems to have it solved. The printer lowers the temperature in the unused nozzle, and there's a tiny little spring steel strip that moves over and blocks it. It knows when the nozzle will be needed again and starts heating it up in advance so it'll be ready, and as far as I can tell, it's timed pretty much to the second. Now, the little metal spring on the nozzle blocker is exposed, so if you do something dumb like I did and start a new print without removing the prime tower from the previous one, it will collide and it will get bent. I was really frustrated when that happened, but it turned out the printer came with spares and swapping in a new one involved 2 screws and took 2 minutes. Just be sure to check it after a collision because the bent spring can scratch the bed. Ask me how I know. The new AMS units are also much improved from their predecessors. The headline feature is that both units have built-in heated dryers. AMS 2 Pro holds 4 spools and can reach 65 degrees, and the AMS HT can hold 1 spool and reach 85 degrees. Both units can rotate the spool periodically during drying for more even drying. You do need to pull the filament back out of the feed mechanism to dry it though, because it gets soft during the process, and you can't dry while printing for exactly the same reason. If it stayed in the mechanism, the feed rollers would deform it as it gets warm. Both units have electronic vent valves that open and close automatically. They stay closed so the dryer can heat up quickly and then open to release moisture. Once the drying is complete, they seal again to keep the filament dry. They claim the AMS is now suitable for long-term dry storage, but I've been swapping materials in and out constantly while testing, so I haven't had a chance to find out how well that really works. The new AMS 2 Pro is also faster than its predecessor and has one huge quality of life improvement. The feed tubes are now accessible from the top. If you've ever had filament break in the old unit and had to take it apart to clear it, you will welcome this change. Now, I haven't actually had to do that because I haven't had any filament break in the new AMS, but that usually happened in the old units after the filament had been sitting in there for a month, so there hasn't been time for that to happen. The AMS units, of course, also have RFID readers to automatically configure the printer when you're using Bambu Lab filaments. But what I didn't realize is that they also use the RFID tags to estimate the remaining filament on the spool. Now, I thought they were doing this by keeping track of the serial number of the spool and how much had been used, but that's not actually how it works. You may notice that it feeds filament all the way down to the printer and then rewinds it during the loading process. Part of what it's doing is measuring how much filament it has to feed before the RFID tag comes around again, and this lets it estimate the circumference of the windings and calculate how much material is left on the spool, which is pretty neat. Yeah, quit talking and just show us the prints. Okay. To test the basic functionality of the machine, I grabbed the Prusa XL rocket engine model and printed it in PLA Basic. It fit in the build volume and just printed with zero drama. The result is pretty smooth and clean. If you pressed me, I would say it's slightly cleaner than the one I printed on the XL, but it's very close, except that the one on the H2D printed about 4 hours faster. Bambu Lab provided some test models that they suggest using to demonstrate the printer. I didn't even look at them. I'm much more interested in how it will work for what I do, so I trolled through my archives and pulled out some of the things I've designed and printed for previous projects. This is an electrical load analyzer I built to get the oscilloscope shots that you will see a little later in this video. The enclosure is printed in carbon fiber nylon using the heated chamber, and it's as clean as any print I've seen in this material. I've gotten in the habit of leaving a 1/4 millimeter clearance all the way around for parts that need to fit together, but when I did that on the H2D, it felt loose. I reduced that allowance to 0.1 millimeters, and the fit is much better. This printer seems to hold dimensions well enough overall that excessive clearance just isn't necessary. I've gotten in the habit of doing that on other machines, and it just isn't needed anymore. This is the PCB soldering fixture I showed in a previous CNC build video. These are printed in ABS glass fiber. Once again, I left 0.1 millimeters clearance for the connectors, and they just slide in perfectly with almost no free play. The H2D profiles for ABS glass fiber have the heated chamber enabled, unlike the ones in the X1E, and I find it helps a lot, especially with larger parts. Speaking of which, here's a larger part. This is the control panel for my surface grinder. This is printed in ABS glass fiber using the heated chamber, and it is really flat. Flatter than the ones I printed in the X1C or the X1E. I think having the larger heated chamber moves the part further away from the edges of the bed, and that helps a lot with materials like ABS that tend to shrink. I printed one in carbon fiber nylon as well, and it also came out dead flat. I was actually not able to print this part in nylon on the X1 Carbon or on the X1E because in those machines, it always warped just a little bit more than I could tolerate, and it just didn't end up fitting on the base when it was done. I did some testing with various support materials as well. This is a little outlet shelf to hold a couple of electric toothbrushes. It's printed in PETG high flow, and I used PLA as the support interface for these curved surfaces, and they came out super clean. I've tried using PLA to support PETG before in other printers like the XL, and I never really got it to work the way I wanted. Here's a multicolor housing for the controls on my drill press, printed using 2 nozzles in PETG and also in ABS glass fiber, plus support material for the overhangs. What you're looking at here is exactly the way they came off the printer on the first attempt. I did the project originally on the dual nozzle Cheedy iFast many years ago, and I struggled to contain the ooze. There was 0 ooze and 0 contamination in the H2D. I just ran the job and it just worked. The L version of the H2D comes with a smoke extractor hood that attaches to the back of the printer, but I designed my own that exits at a 90-degree angle so I can place the printer closer to a wall. It also has a twist lock connector built in. This is printed in PLA carbon fiber, and the surface quality is just stunning. It's basically perfect. The inside of the twist lock port is almost all overhangs, and they're pretty much perfect too. This is the mating twist lock adapter. This is printed in PETG CF with a TPU gasket. This was printed in one go with Bambu Lab's 90A TPU in the right nozzle and PETG CF in the AMS on the left. The gasket has an air gap behind it, and it's preloaded about 1 millimeter on the diameter so it seals against the hood when inserted. This print also just worked on the first try. When that worked, I had to come back to this control panel project I showed a while back. This part has 4 types and 3 different brands of PETG: black, white, clear, and transparent green, plus 90A TPU for the buttons. And it printed like you see it here on the first attempt with no cleanup. I still need to experiment with different colors to get exactly the effect I want, but the printer handled what I asked it to do perfectly. Now, I actually bought my 5-tool XL specifically for this project, but I could just never get it to print without making a mess. But the H2D did it on the first attempt. I also tried some big prints like this 7x7 Gridfinity tray that pretty much fills the bed. This is PETG CF, and of course it came out pretty much perfect. And when I say perfect, I mean that. I threw it on the surface plate to check and see how square it is. My thinnest feeler gauge is 0.04 millimeters, and I can't fit it between the part and the granite square anywhere. I did use the special plate to run the vision calibration on the printer, and it works apparently. I didn't really focus on the laser or the blade cutter, but I did at least try them out. I cut out cork and foam gaskets for my smoke hood using the laser, and I cut some 3M 468MP transfer adhesive with the blade cutter to adhere them to the hood. Now, I've never used a blade cutter before, and I haven't done any through cutting with a laser before, but both processes were simple and intuitive and just worked. If you haven't picked up on it, that is a running theme with this machine. Bambu Lab's slicing software is called Bambu Studio, and it directly integrates with Bambu Lab printers and cloud services to send jobs and monitor printing. If you're using Bambu Lab materials, the printer reads the RFID tags in the spools and synchronizes this information into the software, so you can just select your filaments and print. It has profiles for all of the materials they sell, and in most cases, the default settings yield great results. You still have the ability to tweak, but you don't have to if you don't want to, and I don't want to. When you send a job to the printer, the software prompts you to load the correct materials and recommends where they should be placed between the AMS units if you have multiples and the 2 nozzles to minimize waste from filament swaps. You can override this if you want, or you can tell it to just use them where they already are loaded, and it tells you exactly how much filament this is costing you. You can, of course, use third-party filaments, but you get a lot less help because the machine can't automatically tell what's loaded. And while there are profiles for some popular brands, there really aren't that many. The more I use my Bambu Lab machines, the more I appreciate the RFID tags. Have you ever had a print fail because you had PETG loaded and you told the slicer it was PLA? Yeah, me too. So I will take all the help I can get. And I probably pay an extra $2 a kilogram for the Bambu filament than I would for cheaper options, but I consider that money well spent. They also have a mobile app called Bambu Handy that connects through the cloud to monitor the printer and view the camera feed. It provides notifications and allows you to intervene if anything goes wrong. So I routinely start a print right before heading out the door and monitor it from my phone. And I find that to be a huge convenience and a huge time saver for me. The H2D is good, but it's not perfect. I'll share 4 issues that I ran into during testing. First, you should be aware that this thing can draw a lot of power. I think in the specs it tops out at over 1300 watts. It has a large bed and it heats up fast, and that has a cost. It's not that the total energy consumption is excessive, that's governed by the laws of thermodynamics. It's just that the peak power draw is high. I had issues with LED bulbs on the same circuit flickering slightly as the bed heater cycled. I tried to capture it on camera, but I just couldn't. It's more something annoying that I noticed in my peripheral vision. I did some measuring and I found that the printer is actually very well behaved. The switching is clean and it occurs on the zero crossing of the AC waveform, which is exactly how it should be done. It just pulls a lot of current and it was causing about a 1.5% voltage sag on the line when the bed heater switched on. Now that's well within the allowable 5% where I live, but it was enough to trigger the LED bulbs. I tested some different brands and found that Philips bulbs were not affected as much, and moving the printer to a different circuit solved my issue completely. Bambu Lab tells me that there is a firmware change coming to make this better, but I haven't seen it yet. Just realize that you're probably not going to want to run 2 of these printers on a standard bedroom circuit. And if you were disappointed that the printer wasn't as big as you wanted, just know that that problem would be worse with a larger bed. Second, I discovered that during a long print, it is possible for filament loaded in the unused nozzle to fatigue and break. I was using PLA to support PETG, but it was only used in the first 2 hours of a 34-hour print. During the remaining 32 hours, the PLA was just along for the ride. It didn't feed at all, and the constant motion of the head caused it to break in the tube, so the printer then couldn't unload it at the end of the print. I didn't have any problems with a shorter 8-hour job, but 32 hours of constantly flexing without feeding is too much for standard PLA. I spoke with the engineering team and they said they'll likely add a feature in the future to unload filament that isn't going to be used for a while. Again, I haven't seen that change yet, so I can't say when or even if it'll ever be delivered, but it is just software, so it should be an easy problem to solve. Third, my unit started making a light squeaking noise after about 150 hours of printing. The support team told me this is not common, but it's caused by the belts rubbing on the pulley flanges. They sent me a video showing how to lubricate the pulley flanges with a tiny bit of grease, and that seems to have solved the issue for me. Is that a permanent solution? I don't know, and I've never heard of lubricating timing belts, but I'll keep an eye on it. My printer was actually dropped and had some minor damage in shipping, so that could be related, though I haven't seen any other mechanical issues caused by that. Fourth, and finally, the pre-release software I used for testing has a couple of temperatures in the default profiles that don't seem right to me. The default profile for PETG-CF was set to 255, which does work, but depending on the geometry of the part, I found that the print quality was better at 265. The default temperature for PETG Basic was set to 220, which, technically works, but again, the print quality is much better up around 250. I've provided that feedback and we will see what they do with it. I think they're trying to use lower temperatures for PETG so it'll print better if it's wet, and with some geometries that works, but I would much prefer tuning for maximum print quality for knowledgeable users instead. You can, of course, just set the temperature yourself, but that kind of undermines the value of the ecosystem because it means you can't just let the machine read the RFID tag and take the defaults. You have to tweak the profiles, which, if I didn't already mention, I despise. So should you buy this printer or this printer? Well, I can't tell you that. It really depends on what you want and need. If, like me, you love your other Bambu Lab machines and you've been waiting patiently for a bigger one with a heated chamber and TPU support, here it is. And I think it more than delivers. Or if also like me, you bought a Prusa XL with high hopes but ended up frustrated and disappointed, this is an option you should consider. And finally, if you are in the market for a big 3D printer and a diode laser and a blade cutter, and the work envelope of this machine is big enough for the things you want to do, this could be a good all-in-one solution. On the other hand, if the cloud connection is a concern for you, or if you're looking for third-party interoperability, this might not be right for you. There are LAN-only, developer, and autistic modes that may meet your needs, but that is not the design center for this machine, and I would not feel good telling you to buy it with confidence that everything will be open forever. It is what it is, and if that's not what you want, you probably won't be happy. For me personally, this ticks all of the boxes, and if they hadn't sent me a second one, I would have bought another one myself. I need tools that just work. I don't need another hobby. Well, I hope you found this useful. If you did, and if you want or need to buy one, there is a link down in the description. Using that helps support the channel, but if that's not your speed, no worries. I still hope you found this useful. Thank you for watching.